All right, here we go with the Unit 2 review in preparation for our upcoming test. Just a couple of reminders out there. You will be having your assistance like you did before. If some of you on this first part are concerned, again, you will be given this kind of help sheet with your focus and directrix and some other general information about parabolas to try and help you out. So no worries there. Here, when I get working on having one of my parabolas in standard form, to find the x value of my vertex, simplest way is just to do negative b over 2a. So I'd have the opposite of 2 would be negative 2 over 2 times negative 1/2, which would be like being negative 1. So negative 2 divided by negative 1 is going to be 2. And at this point, my suggestion, because again we want to do some things that have some speed here. My apologies for that there. My calculator's decided to go a little crazy. But instead of trying to plug all of these in and taking up all the time that would be necessary in doing that, what I would suggest instead is going ahead, getting this into your calculator in as timely of a fashion as possible, and once that's situated, using my table to get my other information out. And I also am going to see again with my symmetry that I've made the correct decision in getting my x value for my vertex, which is correct, which would be a 2, 3. And then basically I'm just going to take some of the rest of these, get myself several points so I get a nice smooth curve. My axis of symmetry again is just the x value of my vertex. You have to have the x equals. If you just put 2, that's not telling me that's the equation of a line, so you do need to have that. My focus, as we had up before, is going to be h k plus 1 over 4a. So my h, of course, is 2. My k here is going to be 3 plus 1 over 4a. Half of 4 would be 2, so this becomes the equivalent of 3 minus 1/2. Negative 2 would make this 2.5. If you put 2.5, that's okay. My directrix then is the same as my focus, except it's y equals and it's k minus 1 over 4a. So now instead of minusing the half, I'd have 3 plus 1/2, which is going to be 3.5. Okay. So, as we work through these, we kind of work, that's actually the one that's going to take the longest out of all of these. The rest of them should flow pretty smoothly here. My vertex here in vertex form, I'm ready to go. Gets me my axis of symmetry right away. And then what's going to end up happening is, again, my focus and directrix. This time my a value is 1, because there's no value in front of my quantity, my parentheses. So it would be negative 2 here, negative 2 plus 1/4, which would be negative 1 3/4. My directrix, and some of you may start to notice this, you have your equidistant from your focus, and again, that's not our real bell, that's just the bell because I'm working between classes. I'm 1/2 away here, so I'm also going to be 1/2 away on the other side for my directrix if you're looking for that shortcut. If you're not comfortable with the shortcut, and there's never anything wrong with not shortcutting things, bk, and instead of the plus 1/4, it would be the minus 1/4 this time. So minus 2 1/4. So once I get that up, I can go ahead and get this graphed. Now me, this time, this looks easy enough, I'm not even going to bother with the calculator. But let's say, for instance, I had 5. 5 minus 4 is 1. 1 squared would be 1. So 1 minus 2 is negative 1 for both of those. And then let's try 6 and 2 out here. 6 minus 4 is 2. 2 squared is 4. 4 minus 2 is 2. Again, that'll get me a pretty accurate depiction. If you wanted to just plug that into the calculator once you knew the vertex and use the chart, that's perfectly fine too. So here then, my domain, my x values, we've talked before about how this is always going to be negative infinity to infinity because these are just going to keep expanding and going upward, but my range does have a bottom point down here at -2. But then it goes up forever to infinity. So just something to keep in mind. Then, intercept form. A lot of times this will be the easiest. I find my two intercepts by setting my quantities equal to 0. To get my vertex x value, I could go ahead, add those up, divide by 2, or I could count with my fingers. -2/2 is -1 is my x value of my vertex. And then to get my y, again, I have several options. Some of you may go to a calculator on this. I really don't think you need to, because here you go, okay, -1 plus 7 would be 6. -1 minus 5 is -6, so it's -36. A ninth of that just is divided by 9. So my y value is going to be -4. So -1, -4. Get my parabola in there. -1, -4. My axis is still my x value. My domain is going to continue to be negative infinity to infinity. And my range, again, bottom to top. Bottom to top. And again, I'm using the bracket because that value is included within my solution for this one. Solving by factoring. Again, if there's anything that can be factored out ahead, you need to do that. Some of you before on the quiz didn't do that. You factored everything out correctly, but it wasn't simplified as much as it could be by having the 2 taken out. Once I get here, I just need two numbers that multiply as +7 and add to -8. -7 and -1. Solve. That's what the equals is for. So anything that has an x gets set equal to 0 and solved for. Nice thing if you're ended up watching this at home is you can like pause me, rewind me, and things. I just want to make sure that we can get all of this in and let you see everything. Here, the shorty, difference is squares. What do I square to get 64? 8. What do I square to get 25? 5. And again, set those each equal to 0. So in one we'll subtract the 5 over, the other will add it. And we're good to go. Here, simple diamond type problem. What multiplies to -24 and adds to -5? -8 and 3. Again, don't stop, you're solving. And when I set those equal to 0, I basically just switch the signs on each. Now, last one. Now, you might look at this and say, wow, that might be a little bit complicated to work with here. Not really, because notice your first and last terms. Sort of like what we had in 5, we have perfect squares abound. So when that happens with your first and last terms, what do you square to get each one? And then we just get a plus in the middle, because 28x and 28x is 56x. And again, this is mental math. It's just something you've got to keep practicing, got to keep working with. So when you're doing these, that's kind of important. Since I have the exact same quantity for each, I only have to do this once. And I get my single solution for that one. Okay, otherwise just known as like a double zero. Solve using square roots. Answers must be exact, which means no decimals, and simplified. So if I divide by 2, because my first job is to get my x squared isolated, then take the square root. Remember, I'm looking for at least one number here that's a perfect square. 9's a perfect square. I also, man, so many things to remember, have to keep in mind that since it's a quadratic, it's plus minus. Square root of 9 is 3. Okay, no i's yet, no negatives. That'll be coming. So as we continue to do these, again, your first order of business is to get your x squared term isolated as quickly as possible. So plus the 8, divide by the 4, square root it, and again, if you can break down the radical, that needs to be done. If you just leave it as plus minus square root of 12, you'll have a deduction for that and get my answer. Now 10's a little different of a story. We do not want to FOIL this all out and do it. That's too much work. What we're going to do is just get rid of that squared right away. And again, if you can break things down, that needs to be done. So 4 and 6 multiplies to 24, breaks down to 2 square root of 6. And then subtract the 8 over, but again, it's just hanging out on the side with our plus minus 2 square root of 6. You're not trying to like add that to this. Won't work. But again, it's about isolation with that. Now, as we get down below, be careful. There's no equations down here, so there's no more plus minus involved. That's one of those little detail things you don't want to get into and start losing partial points. But we do now have the return of I. Get that negative out of there. I square root of 169. And the square root of 169 is 13. So it's just 13i. So then I get up to number 12. And I'm like, okay, I got to pull an I out. Square root of 81 is 9. And then remember, my little root number out here is 2. And it's always exponent divided by root. 8 goes into 2. Well, 2 goes into 8, excuse me. 4 times root and exponent. Now 2 doesn't go into 7 evenly. But remember, however many times it goes in fully gets out. And then whatever my remainder is what has to stay underneath. So if we have something that doesn't go in evenly, whatever the remainder is, if you did old school division, would have to be stuck underneath. 13 and 14, biggest things here. Well, even 15. These are not, I repeat, these are not FOILing problems. They're plus and minus in the middle. Do not FOIL these. Just combine like terms. Yes, it is that simple. With your negatives, watch your signs. Lots of you on the last quiz just got sloppy because you got going so fast with your signs here. If it takes you that extra 10 seconds to actually write it down so you can visually see what's going on, do that. Don't need to be in a big rush. Here, distribute. You don't get bonus points for getting the right answer without showing me anything. Now then 16. Again, I got to rewind myself here for a minute. I got to remember about my i's. Well, I know that I is the square root of negative 1. And I know that I squared, if I were to square a radical, just leaves me what's underneath. And I also know that I to the 4th would just be squared times squared, so that would be positive 1. And then I to the 3rd is just I times I squared, which would give me a negative I, or a negative square root of negative 1. So when I get here, by my exponent rules, I have I to the 8th. And I can look at this one of two ways. I can either go 1, 2, 3, 4, 5, 6, 7, 8, get my answer. Or you can do, like we've discussed before, dividing by 4, and whatever the remainder is would give you your answer. Well, 4 goes into 8 evenly, so it just tells me it's going to be that particular value. All right, moving on. Now it's time to FOIL. Now we're going to get I squareds we're working with. So we've got first, outer, inner, last, but there's two things I've got to be aware of here. First, since I squared equals negative 1, that basically is going to take this whole part and turn into negative 48 times negative 1, which is just plus 48. I squared, see you later. 15 plus 48 is 63. Negative 12 plus 60 is 48. Good to go. 18. Most of you were good on this one. We did it in the quiz. Multiplying by the complex conjugate. fancy way of saying change the sign in the middle of whatever your denominator terms are. And then FOIL it out and simplify. So here I've got 6 minus 24i plus I minus 4i squared. And down in the denominator, I've got 1 minus 4i plus 4i minus 16i squared. But I remember my I squareds, just basically change the sign of whatever I see. So we'll get those fixed up. 6 plus 4 is 10. Negative 24 plus 1 is negative 23. Those guys cancel. 1 plus 16 is 17, and I'm good. But you have to make sure that you're multiplying by the complex constant. Change that sign, otherwise you're going to be in trouble. Okay, back to quadratics. Get that x squared alone. Get it alone, get it alone, get it alone. Remember, it's a quadratic. Plus minus. There's a negative in here. So I gets to pop out, because normally this would just be 2 square root of 6. But the I pops out with when I'm dealing with a negative. Similar to what we did earlier, do not distribute this 4. Do not FOIL this out. Get that negative 4 out of there. Square root it to get rid of the parentheses. Okay, that one turns out nice. Negative 36, so square root of 36 is 6, so along with the I. And then subtract the 7, and I'm good to go. Now this next part, and I just want to repeat this again. Some of you, when we got the quizzes back, went a little too fast with these, even though you did a lot of things well, and it messed you up. So when you're completing the square here, it's fine to skip a step, like if some of you know half of negative 2 is negative 1, squared is 1, and you don't have to do all that, and you just put plus 1, that's okay. If the same thing happens with y here, y squared plus 8y, and you've got this, and you do it all in your head, and you're just all that, that's fine. Here's the part you've got to be careful on. That 8 that moved over here isn't the only value over there. These 2 values that you use to complete the square also need to be added in on the right side of your equation. And that's what a lot of you forgot. When I'm going to turn these into my binomials, again, just steal the b divided by 2 value for each of those. And I'm in standard form for a circle. Opposites for my center, and square root for my radius. And the same exact thing's going on in 22. Again, take half of your b, which is 3, and square it, which is 9. For my y's here, half of negative 18 is negative 9. Square it would be 81. My negative 26 is already out of the way, so I'll just add the other 2. Half of 6 is 3. Half of negative 18 is negative 9. And 90 minus 26 is 64. Switch my signs. Square root to get my radius. And I'm good there. And basically we're going to be doing the same thing when it comes down to 23 and 24, except don't have to do it twice. So x squared plus 8x, half of 8 is 4, squared is 16. Get it into my binomial form, half of 8 is 4. Now it's like the problems we were doing up above. Square root to take care of that squared term. Don't forget to break down your radical and do your plus minus. And then just minus the 4 over. And it's the same for any of these. Half of 16 is 8. 8 squared is 64. But that 24's got to be to the other side, so that'll make it negative. Turn it into its binomial form. Half of negative 16 is negative 8. Square root, if it breaks down, do it with your plus minus. And add the 8 over. Oops, kind of went off the screen a little bit there. Write in vertex form, completing the square, identify the vertex. So our one last time that we completed the square, again, this is the one where I'm going to isolate my x's on the right side of my equation. Half of negative 12 is negative 6. Quantity negative 6 squared is 36. That gets added once to each side. Turn this into its binomial form because half of negative 12 is negative 6. And subtract the 36 over to get it into vertex form. And my vertex would be at 6, negative 12. Then probably one of the easier questions, add these complex numbers. Okay, 7 and 12 is 19. Negative 6 minus, oops, my plus, I almost lost it there in my marking. So 4 minus 6 is negative 2. And that's it. Get my label on, nothing else to do. So again, keep it simple. Area of a rectangle. Area is length times width. Length times width equals area. Now here you have a choice. And I'm going to bring the 117 back over by subtracting it. I could try to factor this first, and it very well could be factorable. But do you really want to mess with that much and figuring out the different numbers? If you know off the top of your head, great. If you don't, go use the quadratic formula and keep it simple. So here, for instance, and I'll put down the factored form in a minute because it actually could be factored. So it's going to be negative b plus or minus the square root of b squared minus 4a, oops, negative 117, 4ac, all over 2a. Because again, we want to do things that are respectful of the time that we've got to work with here. So 25 minus 4 times 2 times negative 117, okay, is 961, and just take the square root of that, which is 31. So 5 plus or minus 31 over 4. I know with it being the side of a rectangle, 5 minus 31 is going to get me a negative. That doesn't make any sense. So 5 plus 31 is 36 over 4, makes my x 9. My dimensions then would be 9 by 2 times 9 is 18, minus 5 is 13. If you would have factored it, I'll show you what the factoring would have come out to. So you can see that we'd have been basically in the same place. I'd have gotten a negative when I solved this for my 0, but x minus 9 set it equal to 0 would have gotten me 9. So factoring works, quadratic formula works. Again, we always want to be flexible as to what's available to us. Moving on. All right, Niagara Falls is 214 feet high. How long does it take for water to fall from the top to the bottom? Okay, bottom, this is going to be where we end. This is our initial height. Now again, I have choices. When I get to here, if I am comfortable with the calculator, I could absolutely go ahead and just type in negative 16. I'll use x instead of t squared plus 214. Now you're like, okay, how long does it take for it to fall from the top to the bottom? In other words, how long is it over here when it hits 0? So I want a 0. I'll click until I start. There he is. And again, I use him to trap above and below. He's down here somewhere because I see the y value is negative. And I find out it would take about 3.66 seconds. Now, if I'm not comfortable playing with the calculator that way, my other option is I could go ahead and solve this for t and just do it algebraically. So if I were to minus the 214 over, then divide by negative 16, which would leave me with 214 over 16 equals t squared, I'd still need the calculator. I'd just use it in a different way. So I do the square root of 214 divided by 16, and I get the same answer, about 3.66 seconds. Or if you did 3.6, well, in this case 3.7, I guess, since I didn't tell you what to round to, that'd be fine too. Staying in that type of idea, though, Michael throws the ball upward, so notice I now have an initial velocity. Speaking of that, initial velocity is going to be 45. It's that value in front of my t. So, what's the maximum height reached by the ball in the time that it's reached? Again, it's options, but we're so reliant into the calculator here, that's probably going to be my best route to go. And again, I'm just going to use x instead of using t here. So I look and it says, okay, what's the maximum height? You're like, I can't see it. That's okay. We've got this. Oops, we want zoom. Remember, we're going to zoom to fit so I can see it. And then I'm going to go find me that max. And again, anywhere to the left of my vertex, that's fine. It'll be here. And this time my vertex is going to be my maximum. Anywhere over to the right of it's fine with an enter. And I find out, move this over a little, that it reached 39.6 feet at about 1.41 seconds. Now, could I have gotten that without using the calculator? Yes. I could have, to get my, because I noticed this is my x value and this is my y. To get my x, I could have used negative b over 2a. So if some of you are a little gun shy about using the calculator and the graphing app, you have a backup plan. There would be my time. And then I would just take that value and I would just call it 45 over 32. And I literally would type that into the equation. Now again, does this take a little bit longer than the other way does? Well, yeah, it does. But I still get to the right answer. Okay, so don't let the graphing calculation get you. But I will admit, when it says complete the table, this is where you really do want to have typed this in. Because now I can just go to my table and I can fill in the values to go along with it. And when it says find the average rate of change, remember rate of change back from Algebra 1 is just a fancy way to say slope. So we're doing an application here. We've done all this. It's a little bit different, but it's nothing we can't do. And again, my time is always going to be my x. My height's always going to be my y. So think about slope. Slope, it's the difference in y. So negative 68 minus 34 over the difference in x. And yes, it's okay to get a negative slope. But again, I'm going to work with a label here. Once it gets there, it's heading downward now at about 51 feet per second. So, just an application for us to work with a bit. Okay, solve using the quadratic formula. On these, again, just a reminder, negative b plus or minus the square root of b squared minus 4ac all over 2a. Four times 3 is 12, times 5 is 60, all over 2a. If you get something that breaks down clean, like the square root of 4, okay, that needs to be broken down. Don't leave it this way. 8 plus 2 here is going to be 10 over 6, which is 5/3. 8 minus 2, which is 6 over 6, which is 1. Now, will they break down clean every time? No. If I look at this next one, b squared is 25 minus 4 times 1 is 4 times negative 8 is negative 32, which becomes plus. Square root of 57 doesn't break down at all. So this time I can't do anything. So you can see this is going to vary up some. Negative b plus or minus square root of b squared minus 4 times 4 is 16 times 2 is 32 all over 2 times 4. Here, my number itself doesn't break down, but an I needs to be taken out. But that's all I can do. Okay. So those are our three situations possible with the quadratic. Describe a quadratic function that has one real solution. Okay, let me give you a visual here. One real solution. Crosses the x-axis in one place. 1x intercept. Okay, two real solutions. Crosses in two places. 2x intercepts. Two imaginary solutions. Ooh, never crosses x at all. Maybe I have one up here that doesn't cross, or down here, but make sure your arrows don't make it that it goes and crosses anyway. 0x intercepts. And we're set there. Whew, we finally made it to the last page. All right, graph the following. Now again, here, if you want to, it can be as simple as understanding here. If I was looking at this, I don't have a b term. So I know if I go to do my vertex form, it's -0, which means my vertex x is going to be 0. So it would be at 0, 4. And again, this is one of those where I want to save myself some time when I can. So -x squared plus 4, give me a chart. -1 and 1 are at 3. -2 and 2 are at 0. It's dotted because, again, it's just not or equal to. That does make a difference. And again, remember, if it's my y, and that's what f of x really is, it's just function notation. If it's down and less than, I shade in here. If you don't remember that, like I said before, find a point inside, like 0, 0, that's great in this case, and plug it in. Is 0 less than 0 plus 4? Is 0 less than 4? Yes. So I'd color inside. That's my other way of looking at it. If I move to the next one here, again, to get my vertex, -b over 2a. My x value is 2, and again, I am looking to save time. So I get back to my y equals, I'm going to type this in. Go to my table. I know my x value is 2, so I should see symmetry when that's in the middle. Oops, -2. It would help if I went to the right value, right? That's better. So my vertex is at -2, -7. And then again, we just get some of the other values in here from the chart. It's our equal to, so it's solid. Y is greater than when we're opening up, color in the middle. Or use a test point somewhere in here. And again, if it's true, I'd shade inside. If it's false, I'd shade outside. Down the home stretch. Solve the inequality, write your answers. Okay. Remember what we talked about with these. Once they're factored, and again, at this point, you should be running them off as fast as I am with this. Once I know what my zeros are, this less than tells me this is an and statement. In other words, I'm going to be going with my least value to my greatest, and it's just going to be in between. Could I draw out a number line? Yes. Is that going to get a little time consuming? Yes. So when I'm doing these, again, it's all about recognition that I can graph right away, or in this case, factor right away. Greater than, if my quadratic is greater than, that's like an or statement where they go out. And when that happens, we go from -infinity up to our first value, and then from our second value back off to infinity. And then down here are the ones that we did that we kind of liked yesterday. I can do them algebraically, but again, this is now about being able to get things done in as quick of a manner as possible. So I'm going to look, oops, get our window back to normal here. Okay, looks like we got one spot, and it looks out here about 9, 10, somewhere in there. So again, let's get down towards those values. And I'm like, oh, this one isn't coming out as nice for me. Now, when I went and looked at my chart, I didn't see anything to working with that. So let's change this up a little bit. Let's extend our x out to 20 here. Now, it looks like we've got ourselves a spot here. So let's try finding the intersection like we did for a little bit. So there's my curve. There's my second curve. And I've got an intersection that's at a really crazy number here. Let's see. My x value is at 10.27. So I could check this out. Because again, we don't find them come up this strange very often. Just a hint, they're not going to come up this strange on the test. But I can double check to make sure. So 10.27 plus 8. And then is that the same as 10.27 minus 6? Basically, yep. So that one works. But like I said, just a you and me hint. Won't be that bad. Here, I want to isolate my radical. So let's see if we have a little better luck this time. All right, so we got the square root of x, and we've got x plus 2. What did I do? Can somebody tell me? Somebody probably did already when I was doing this last part and I didn't hear you. X minus 2. I got to subtract that to the other side. D to D to D. All right. That's better. Okay. Looks like it's about... let's see here. There we go. There's my two y values that are the same. So it's my x value of 4 Square root of 4 equals 4 minus 2. Yes. Okay. One more. And again, we have trimmed some questions off of the test, so don't panic here. The test is shorter than this is, even though we are going to get done with this review before it would be a class period. I see an intersection point there. Let's hope this is going to be nice. There we go. There's my y values that are the same. My x value is 4, and again, I can do it algebraically, but I don't want to have to go through all that time-wise. So we get higher up in math, we got to be able to play with the calculator. Write an example of a quadratic most easily solved by square rooting. Well, you could come up with an example of your own, but I think this one would be. If I get something, I don't want to have to FOIL that out or do something else, so I could just square root, go about my business. Nothing too bad. And then finally, write the quadratic whose zeros are at 1/4 and -6. Now, we talked about this a bit after the homework check. My signs would switch on these, because again, if I were setting them equal to 0, I'd minus 6, I'd plus the 1/4. But again, I can't just leave that. I'm actually going to factor it out to here, work it out to here. And then the actual equation would be to FOIL this out. So let's see, 4x squared, 24x minus 1x is 23x minus 6. Okay, we're getting done with this with about 6 or 7 minutes to go here. But again, the test itself is going to be shorter, but this also shows you got to know your stuff and get going with it. You can't afford to sit around and go, well, I don't remember. So again, go through this again, work through some more of the review problems again, go back through some of the homework, whatever you have to do, but be ready for this one. Good luck.